So we have seen with construction stories and deconstruction stories and then the solving process, we have been able to find, isolate, if you will, the variable and what the quantity that should be assigned to that variable in order to make an equation true. But in those cases, that variable was playing the role of placeholder. And what we're about to do is we're going to see where a variable actually does play the role of variable in the sense of a changing quantity. Take a look here, please. For q is my variable. 4q minus 3 is less than or equal to 9. What I'd like you to think about here for a minute is, whatever happens here, whatever happens over there, we're claiming has to be less than or equal to 9. Now what that means in terms of a number line is this. There's 9 over there. There are lots of numbers that are less than or equal to 9. 9 is less than or equal to 9. It's equal to. But 8 is less than or equal to 9. 7 is less than or equal to 9. 1 is less than or equal to 9. Negative 2 is less than or equal to 9. In fact, anything over here to the left of 9 is less than or equal to 9. So when we solve this, which we call an inequality, what we're looking for is all the values for q that when you multiply by 4 and subtract 3 are still going to keep us less than or equal to 9. So let's see how that plays out. All right, let's start with the story of q. The story would sound something like this. Start with q, multiply by 4, subtract 3, less than or equal to 9. Deconstruct. Start with 9, add 3, divide by 4. So let's work that through. So in the deconstruct story, we're going to add 3, so we're going to get to 12. And if you think about that, 12 minus 3 would get you exactly 9. We're again going to talk about less than or equal to in a minute. In the construction story, we multiplied by 4. So in the deconstruct story, we're going to divide by 4 and say q is less than or equal to 3. 12 divided by 4 is 3. So what I'm claiming is q can be any number less than or equal to 3. 1, 2, 3, here's 3. Q can be any number less than or equal to 3. And to designate that, I'm going to use this number line to say any number. So q could be infinitely many things as long as q is less than or equal to 3. For example, 1 is in there. 1 is less than or equal to 3. Watch this. 4 times 1 is 4. 4 minus 3, 1. And 1 definitely is less than or equal to 9. Or how about somewhere down here is like negative 3. 4 times negative 3 is negative 12. Negative 12 minus 3 would be negative 15. And negative 15 is certainly less than or equal to 9. So as long as q is less than or equal to 3, 4q minus 3 will be less than or equal to 9. So we solve the inequality very much like we solved our equations, but our solutions are not going to be a single number like q equals 3. Our solution is going to be all the numbers q that are less than or equal to, and there's infinitely many of them, less than or equal to 3. Now there's something that kind of interesting happens in this situation, and so before I do this one, I want to set this up. I hope everyone watching would agree that 1 is less than 2. What I mean by that is on a number line, 1 would be here, 2 would be here, and 1 is to the left of, therefore less than 2. Now just for fun, what if I decided to add 3 to both sides? What if I added 3 to 1? That would give me 4. If I added 3 here, that would give me 5. Isn't 4 still less than 5? So the idea is if you increase one side of an inequality and you increase the other side of the inequality by the same amount, you still have a true statement. By the way, that works with subtraction as well. What if I subtracted 3 from both sides? 1 minus 3 is negative 2. Check your calculator if you need to, but 1 take away 3 would take you to negative 2. 2 take away 3 would be negative 1. Is negative 2 less than negative 1? 0, negative 1, negative 2, negative 3. negative 2 would be here, negative 1 would be here. Negative 2 is left of negative 1 on the number line. So yeah, negative 2 is indeed less than negative 1. So as long as we do the same amount to both sides, we're good. What about multiplication? What if we double both sides? Double 1, double 2. 2 is still less than 4. Triple 1, triple 2, 2, 4, 6. 3 is still less than 6. So as long as you double, triple, quadruple, whatever you want to do, you're still going to get a true statement. Okay, here's where it gets a little crazy. What if we multiply both of these by a negative number? Let's do like negative 1. If you multiply this by negative 1, you get negative 1. If you multiply this by negative 1, you get negative 2. Now, what's the relationship between negative 1 and negative 2 on the number line? Negative 1 is to the right side of negative 2. Negative 1 is greater than negative 2. Or watch this, let's do another one. What if you multiply both sides by negative 2? 1 times negative 2? Oops, don't put that there yet. 2 times negative 2. What's the relationship between negative 2 and negative 4? Negative 2 is to the right of negative 4. Negative 2 is greater than negative 4. Negative 2 is greater than negative 4. So it brings us to a principle. If you have an inequality and you multiply both of the numbers in your inequality by a negative amount, that negative causes the inequality to switch over. Just because of the way how negatives work. Negatives are going to switch those greater thans and less thans. I share that because look up here. First of all, I have two variables. I have variables on both sides. So we have to employ that technique first, but then you're going to see something interesting happen. Let's make this story ready. Let's take 7c off of both sides. Now if you take 7c off of this side, you'll get 0c. As you saw in a previous video, if you take 7c off of this side, you got to take 7c off of this side. So from 5c, take off 7c. Now if you take off from the 5c, you take off 5c, that gets you down to 0. But we have to take off 7, so take off 2 more. That's going to leave us with negative 2c. Now 0 copies of c is just 0. So this is just 0 plus 11, which is 11. We are now story ready. Story is c gets multiplied by negative 2. Then we subtract 1 greater than 11. The deconstruct story. Start with 11. First thing we did was subtract 1. Now we're going to add 1. Up here we multiplied by negative 2. Now we're going to divide by negative 2. Now when you divide 12 by negative 2, you get negative 6. Now watch this. This is where you got to watch that inequality. Because we divided by a negative 2, or multiplied by negative 1/2, notice we took half of 12, half of 2 is 1. We multiplied by negative 1/2 or divided by negative 2, we have to flip this inequality. Let me show you why. Suppose we didn't. Suppose we said c is greater than negative 6. In terms of number line, here's what we're talking about. 0, 1, 2, 3, 4, 5, 6. Negative 6 would be here. We would be claiming that anything this side of negative 6 would be true. Let's just do a quick check. Like 2 is over there. What's 5 times 2? 10. What's 10 minus 1? 9. What's 7 times 2? 14. What's 14 plus 11? 25. Is 9 really greater than 25? No. 9 is less than 25. So because of that negative that we had to divide or multiply by negative 1/2, we have to. So the true solution to this thing is any value for c that we prefer, that we like to talk about, that is less than negative 6. 1, 2, 3, 4, 5, 6. There's negative 6. We're talking about all the numbers on this side of negative 6. So for instance, go this way somewhere. Negative 10. Negative 10. Let's check it. Negative 10. 5 times negative 10, negative 50. Minus 1. That would give me to negative 51. 7 times negative 10, negative 70. Plus 11. Negative 70 plus 11. Negative 70 plus 10 would get me to negative 60. Negative 59, I believe. Negative 51 is indeed greater than negative 59 because on a number line, 10, 20, 30, 40, 50, 60. Negative 59 would be about here. Negative 51 would be about here. Negative 51 is on the right side of negative 59 by a little bit. And so that statement actually is true. So what I'm saying is, the solution to this inequality is any value for C that is left of, less than, the left side of negative 6 on the number line. Here is the picture of it. Hope that helps.